Alright, so question 10 is about the inequalities and is about the quadratic graphs as well. So first of all, we have the graph. The quadratic graph is intersects at the x-axis. So intersects because they didn't specify how many intersections are there. So it actually can be two cases. So we can just have one intersections, or we can have two intersections, isn't it? So for these two cases, we can just talk about the delta should be, for this one is delta equal to 0, and this one is delta greater than 0. So we can say that the delta should be greater or equal to 0, because the two cases want to include it at the same time, isn't it? Again, because they told you it's intersects, they doesn't talk about is it just touch it or it's actually cross it. It just says that the intersect. Then we need to talk about the two cases at the same time. So the delta means the determinant, so we need to calculate the b squared minus 4ac is greater or equal to 0. So in this equation, we have the a is equal to 1, b is equal to negative, bracketed 2k minus a minus 3, and the c is the negative 3k. So a is the number in front of the x squared, which is just 1, and the b is the number in front of the x, so it's going to be negative bracketed 2k minus 3, and the c is the number without any x, so it's going to be negative 3k. You can just substitute all of the things into it. So negative 2k minus 3 squared minus 4 times a times c should be greater or equal to 0. So negative squared, so it just becomes positive. So we just need to consider about the 2k minus 3 squared. So it's giving you 4k squared minus 12k plus 9. And the negative 4 times negative 3, giving you positive 12k. Is going to be greater or equal to 0. And then now the negative and the positive is actually just cancel each other. So we have 4k squared is going to be plus 9 greater or equal to 0. So now it's the tricky part. You need to solve this inequality. But if you try to move the plus 9 to the left hand side, it becomes negative 9. And we have k squared is actually greater or equal to negative 9 over 4. So now you can think about k squared must be a positive number, isn't it? But now should be greater than a negative number. Then actually, no matter what the value of k is, the whole inequality is actually hold. So that we can say that for any real values of k. So I say it again. So we have the 4k squared plus 9 should be greater or equal to 0, isn't it? We try to solve this inequality. So k squared, 4k squared plus 9 is greater or equal to negative 9. K squared is greater or equal to negative 9 divided by 4. You can think about, is there any number apart from the imaginary or the complex number? Any real number that is going to have a negative number? So it's actually impossible, isn't it? So no matter what numbers you put into this inequality, it's actually hold for all values of k. So that the answer should be all real values of k. Okay?